I'm C Bothma. I work for NVIDIA on NVIDIA Omniverse um, for the AEC industry. I want to do a quick little talk just on a concept because it's only a 20-minute talk on exploring the role of technology in advancing human design capabilities and experiences. Those two are quite important. Now, I understand most of the audience use advanced computational functions, they create tools and write scripts and so forth, but it's really here to make you understand of technologies and the movement in technology at the moment that's going to bring the next wave of tools that we may very well develop, the audience and beyond, for the actual majority of the industry, the users and the designers, and how they will actually do their day-to-day job in designing buildings and cities using these new tool sets. Now, it's important to start from scratch. Again, just bear with me here. I'm not going to give exact dates because everybody has their own version of dates, but understand where we started pre-technology as such. And I'm going to refer mainly to the AEC industry, not to the manufacturing or automotive or the P&IDs and engineering and so forth, but mainly to the architectural, engineering and construction industry. So about 40 years ago, um, most practices didn't use computers. Everything was done by hand. Everything was drawn by hand. And the designer and the creation was done almost in the same moment, in the same space with other designers alongside of them. Production was done by technologists, but the whole process was very much in the moment. And then we went into CAD, and CAD actually allowed us to use digitizers and masks to input these and do a computerized version of technical drawings. It did accelerate the function of reproducing and changing drawings very much so, but it was still a 2D drawing mode, just a different tool inset. And then, of course, into the sort of 2000s, before that as well, but very much into the 2000s, we ventured into 3D, we ventured into BIM, very much into computational design, and this allowed the acceleration of productivity as well as the ability to build certain types of buildings because we could compute certain things we could not compute before. The planarity of facades and complex buildings, etc., etc. So the process become more computer heavy, and the design process was slightly integrated with those compute functions. And then, of course, this is just an example of where we started seeing the first level of democratization, where before with BIM and with computational design, it was very few that had the technical or the computational skills to do that. The same with visualization. Maybe 10% of the office could really visualize great renderings. And sort of in the 2015, 2016 space, it kind of got semi-democratized where 90% of the office could really click a button and get an image out that was good enough for the purpose that they wanted to do. And it's an important point to note, right? Not the fact that it was almost as good enough, but the fact that it was really just a button push. It was an easy interface for a designer that could not visualize to visualize. And then, of course, we went into 2022, and just before that, there were quite a bit of development on AI. For many, many years, NVIDIA was involved with many of these driving the progression of these tools and doing research, etc. But it was really when, in mid of 2022, it became publicly available for anybody to consume. Before that, you really had to have really high computational skills and knowledge to be able to understand models, train them, build your own models, and deploy these. And really, after the mid of 2022, it was available to anyone. So practices were wanting to be AI enabled to be AI enabled overnight. The application, of course, was how they consume this. Just a little side note, and something I've noticed now is that I generated these images, of course, through diffusion models, and it's quite interesting that the drawing images show older people, and the new images on using diffusion models and GPT show younger people. Maybe there's a message there for us. And anyway, so right now we are really entering this age of distributed AI. As I said before, AI is now available to almost anyone, and how they consume it and how they use it is what's giving them the benefit and the edge. But when we look at this kind of progression, this is the point I'm trying to make here, is that if we look at how much time the human spent designing and thinking, pre-CAD, it was really almost all the time. Everything they were doing was purely as a design function, and software knowledge was non-existent or barely existent. They didn't have to know software, they didn't need to know tools or computers or anything like that. And as we progressed through CAD, it kind of started merging, and really after 3D and computational side of things, your output was quite amazing, but your actual design input was less. It was more that you were a computational or advancedly skilled at specific software, right? And that kind of became a little merged. The graph doesn't show it 100% here because it's just a sort of very quick sketch that I did here, but it came very, very merged in terms of how much design you're actually doing and how much you're spending creating the design using software and hardware, right? And you probably find that you spend 2 hours designing and 6 hours trying to model your design. And yes, you are designing when you're modeling, but it's not pure intuitive human nature of design. And really this point of AI now is driving it into the flip side again, where, and again, maybe to the images I showed earlier in terms of the age, where AI allows anybody to partake in high level of compute that give them feedback. It doesn't have to be specialist, right? And you see it in your offices as well. Some of those that are incredibly good designers may not be really good at computer modeling or computational functions or analysis functions and so forth. They need to give that to somebody else. Now all of a sudden the playing field is quite open and everybody can partake in advanced design functions with compute moved away from them, right? Compute almost as an easy interface to the human and allowing them all to work in the same sort of space. There's democratization and the use of AI to assist us in natural ways of designing. And we see this with functions like even coding and the likes. With coding, of course, if you know C++ or C# or Python, it is a major advantage. But if you speak English, you could also semi-code. So this point that I'm driving for quite a while now already is the fact that the human interface to compute allows the human to be focused on their specific task. Compute is slightly moved away. This is exactly what we do at NVIDIA. We allow all these SDKs and functions to help do what you want to do, and it brings back this real-time experience back to you. So when you interface through sketches or through speaking to the computer or through a mouse or through coding, whatever your design thought process is and how you interact with the computer, it's computed by high compute in the background and brought to you back in real time so that you can make decisions while you work. You don't have to go and do something else, do a last something before you actually understand what your repercussion or your effect of your design process or thought process is. And this is really where we sit with Omniverse at the moment. This is one of those real enablers of high compute, either local on-prem or in cloud, and allowing you to choose your interfaces and your experience back in real time. Now, a little bit just to understand where Omniverse sits. NVIDIA manufactures servers and hardware for advanced computing. We're very well known for our RTX cards and GPU. These are used in high-level visualization and AI and many other industries. And above that layer sits our platform stack. And NVIDIA Omniverse is one of those. And it's really built to consume all our supporting technologies that are supported by our hardware. And these are all of the AI applications and frameworks that are developed not for Omniverse, but as independent SDKs and frameworks to be consumed in all applications. So many of the SDKs and frameworks that we develop are used in other applications, for example. Now, what happens in NVIDIA Omniverse is we have the ability to combine those all together in a one single framework. Omniverse, of course, is also built in a way where it can consume from most of the applications that we use. All the design applications, analysis applications, simulation applications, manufacturing applications, and the likes. And there's connectivity of all these applications to be able to bring that data into Omniverse. We do this through OpenUSD, which is very important because OpenUSD is extremely scalable. And more importantly, OpenUSD can describe your assets or your geometry and your data inside of these stages or inside of Omniverse in this case. So a chair may not be a single piece of geometry. It may be made up of multiple geometries from multiple files, as well as a material file, a simulation file, an animation file, a data file, a file that connects to IoT data, or whatever the case may be. So when you actually place a chair, it has a depth of data and supporting geometry and material functions around it, including simulation functions and so forth. But what's more importantly is that Omniverse runs on OpenUSD. And when we can consume all these applications, it means that we don't have to go and develop for application C to do a specific function. And then we have to go and develop that same function for application 3, for example, because they are working side by side in the practice. Once we're inside of Omniverse using OpenUSD, we can go and do one compute function or one application or one plugin, and we can compute on any of those connected applications, 50 plus applications that we are connected to, which is quite important because it means that the designers can use the applications that they prefer, and we can do high-level compute once on a collection of all these applications. And just to explain that quickly, here we have a block, we have a city model that comes from a certain applications. We have a massing model that comes from a certain application. We don't really care where that massing model comes from, but we have developed a runner compute function that does a facade option, in this case, hypothetical facade option on that model. Now, before we would have to develop runner compute to run inside of Revit, or it's a build function that runs inside of Rhino, or we maybe build it into another application. Here, we don't actually care where the geometry comes from. It runs on any geometry from any application. We had to develop once to run it on all applications. So here's an example I'll be using a little bit more to illustrate this. So here's an interior of a building. This is a 18-story apartment block, where we use various applications from various designers and collated it all in one space. Now, to understand is that these applications, the Grasshopper 3D, for example, or the Revit model, can be live linked. So in this current state, we can see all the applications from all the designers in one space in high fidelity to understand and make decisions and review in real time. When we look at this, when we talk about reviewing, one of the functions of USD is this thing called variance. And we know that architects like to do options. So we can start understanding that somebody is working on different layouts for furniture, for example. So we can have 2 or 3 or 4 or 10 options built into the scene in the state of a variant. Somebody else might be working on the bar side of this, or somebody else might be working on the facade, or somebody might be working on the material finishes and so forth. And they can all have their various options that can be represented in one scene all together. And again, these options are live linked back to the design application. So if somebody makes a change, we see the changes over here. But it allows us to pick and mix and match all these different options together while the designer is actually editing or in a review mode. More importantly, it also allows us on the experience side that I mentioned earlier to go and review these options in the way we want to consume it. So here we're looking at these options, for example, through a tablet. And this user here, for example, wanted to walk around as a spatial movement with the tablet to look at these different design options while changing these variants back and forth. Now, what I didn't mention here is that I was in a VR state in this, looking at this variance, while Christian Seattle was actually changing the variants, and Jay in San Francisco was walking around with a tablet looking at the variants all at the same time, while the applications were linked inside of this application. So again, collaboration, right? And picking the tools that you want to use and experiencing it how you want to experience it, basically from anywhere, is what we enable with NVIDIA Omniverse. Now, furthermore so, and this is important, as I mentioned earlier, we like to consume our SDKs and frameworks, AI frameworks that we develop. It is a really great place as an AI platform because of its visual quality and its simulation functions. So we actually have physics built into it. So the world inside of Omniverse will behave like the real world, which is important for AI training. We recently announced functions like ChatUSD, so you can actually just type in what you want and it will generate you the files and the scenes based on it and based on USD functionality. I think some of you have seen the text to materials. So we have functionality that you can actually type into the type of material you want, and you can actually go and apply that material. So here I'm sitting inside of that lobby space, and I'm saying, can you create me a nice tropical fabric for this couch? I have the couch, one of the couch elements selected, and it will go and generate a pattern for me and apply it to my geometry, right? Of course, for me to go and find that material, that's the second thing in real life. But for us to create these quick material changes and updates and see the effect of the changes happens real time. Again, we choose how we input data here. We are busy typing, right? And we see that effect of the type of our thought process of what we want to have inside of this model happen in real time and fed back in real time. Now, while we have the ability to generate 3D models from text, in our industry, it's not the most useful thing to do. It might be good for storyboarding or mood boarding and so forth, but what we really want to do is start placing elements based on actual models, actual data. So here we are generating a scene. In this case, we are asking for an entrance lobby type scene, a waiting area scene. And what's happening in the background is we're running multiple AI models here. We're running GPT models and the likes, but we're also running one of our frameworks called Deep Search, which actually goes through all the 3D models in our asset database and automatically capture images of those and tag those together. So if we say that we want an office chair, it will go find out all the 3D models based on color or description or whatever the case we want to put in there of office chairs and bring them up for us to use. And when we use a function like this, where we auto-generate the layouts of these, right, that is exactly the backend system that it's using to go and search those assets and assemble them in a way that makes sense. But again, what's very important here is to know that these are real assets. These are the real 3D models that are validated by us that might have data properties and simulation properties, etc. attached to them. They're not generated meshes that don't mean much for our construction and our design industry. So what we see here is again that bar scene, but here we're using one of our frameworks called Melon, which is allowing us to talk to an application, and you can deploy that in just about any application. Here we have an instance of that deployed in Omniverse, and we are using some action graphs to interpret what Melon is ingesting and GPT is ingesting, and allowing us to flick through these variations as we saw in the previous videos, but using our voice. So the great use of this, of course, is that we can be in a VR moment and actually talk to the computer and see the changes, or we can have users that need to make decision interface with the model without having to understand, again, how to use the software, which buttons to click, or what to do. All they need to do is talk in English or in the preferred language that they are using to cycle through the various options and actually go, well, we actually like this version of it, and we're going to save it as a certain state to go back to it and review that with the final output or the client, whatever the case is. Can I have a view over the bar?
Change view to bar camera.
Can I have a view from lounge?
Change view to lounge area.
Can you change the lounge seating to gold?
Change lounge seating to gold.
What materials can you change off the bar?
The materials of the bar that can be changed are bright and dark.
Change the materials to bright.
Change bar material to bright.
Change the wall to bright.
Change material on walls to bright.
Can I view the pendants?
Change view to pendant lights.
Can you change the dining seating to floating?
Change dining seating to floating.
Can we make the floor polished concrete?
Change flooring to polished concrete.
Can you save this as the bright version?
Your preference for the bright version of the scene is noted and will be saved for future references.
So where this is heading towards, again, is the ability that probably in the near future, we will be able to have conversations and brainstorms where the computer as an interface will be part of that and react to what we do, whether that will be sketching or actually using normal computational functions or input devices like mouse or keyboards, or talking. So while we are discussing things, we may very well well, this kind of layout that we have here and the landscape that we have, can we change it to that landscape and change the entrance to this entrance? And can we make a variation in material in this entrance to see how that actually works together? Again, back to the original start of this conversation that I'm having with you, is that our ability to interface with compute has become sort of democratized and more natural, allowing us to get back to a point of thinking about what we're doing instead of trying to think about how we're going to do it. Let the computer figure that out as a high performance compute function in the background and give us the experience feedback in real time. And I think this is not too far away when we're going to be in that sort of framework. Please reach out to us if you want to know more about NVIDIA Omniverse or any of the NVIDIA SDKs, frameworks, or APIs that we are available for you.